Now let's take a look at the proof of the fundamental theorem of calculus. This fundamental theorem of calculus states that the area under the curve of y equals fx from x equals a to x equals b can be simply calculated by capital FB minus capital FA, where capital Fx is a primitive function of this small fx. To prove this, we can first of all consider an area function at, and we can define at as the area under curve y equals fx from x equals a to x equals t. That means this definite integral. In this definition, we are assuming that this fx is a continuous function. And then the tricky part is to consider the change in this area when there is a very small change in the value of t. And this small change in the value of t is denoted by delta t. And the change in area is denoted by at plus delta t minus at. And then we should know that the length here should be equal to ft, and then the length here is equal to ft plus delta t. According to this figure, when we assume that the curve is increasing, then this area should be greater than the area of this rectangle, and the area of this rectangle is equal to ft times delta t. Similarly, we can argue that the area of this blue rectangle is equal to ft plus delta t times delta t, and it should be greater than the area that we are interested in. This inequality is true only when the function is increasing or a constant function in this interval. In the other case, we can have a function which is decreasing, and then in this case we should flip the inequality signs like this. If we have a case in which the function is increasing and then decreasing in this interval, then we just need to choose a delta t which is small enough so that the function is either increasing or decreasing in this interval, and then this inequality can be true. Afterwards, we can divide all the three terms by delta t. And because we have assumed that fx is a continuous function, this must be true. This limit relation suggests that this term is actually approaching to ft as delta t approaches 0. And because this term is between these two terms, that means when this is approaching to ft, this term should also be approaching to ft. Therefore, we can have this conclusion. And this argument is known as the sandwich theorem. Now when we take a closer look at this limit, we can see that this is just the derivative of a with respect to t from first principles. After all this, we have obtained this important result. That is, by differentiating the area under curve, we can obtain the function of the curve. That's how the indefinite integration comes into play. To get the area function, we have to integrate the function of the curve. In this way, the area function at is equal to capital Ft plus c, where capital Ft is a primitive function of small ft. Now we just need to find c in order to obtain at exactly. Because we have defined at to be the area from a to t, that means the area from a to a should be equal to 0. In this way, we can argue that AA is equal to 0. And that means FA plus C is equal to 0. And then C is equal to minus FA. In this way, we can conclude that AT is equal to capital FT minus capital FA. In other words, this definite integral is equal to capital FT minus capital FA. And if we replace T with B, then we can obtain the fundamental theorem of calculus. This is how we can prove the fundamental theorem of calculus at the high school level.